Hello friends, welcome to Concept Clarity for Physics. Today we will see in detail about how light reflects when it hits upon various types of mirrors, that is polished surfaces. In the subsequent session we will learn about refraction. So today's session is about reflection and the next session is about refraction. Under reflection we are going to cover about light. We're going to see laws of reflection. We're going to cover about mirrors, the different types of mirrors, plane mirror, concave and convex. We're going to see the sign convention and the ray rules for all these mirrors. Then we're going to see image formation of these mirrors, specifically concave and convex. And then we're going to see all the formulas. And refraction we're going to take in the next session. So let us move ahead. Now, before we understand reflection, how light behaves with a polished surface on the reflecting side, let us understand light's nature. So what is the nature? What are the properties of light? When we talk about light, light is actually a disturbance. When we see light, we get disturbed or we get awake, we get alerted. That is why it is called as a wave. And it's an electromagnetic wave. Why it's an electromagnetic wave? Because it has two properties, that is electrical property as well as a magnetic property. That's why it's called an electromagnetic wave. And unlike sound, light does not need a medium. It can travel in vacuum. What is the speed of light in vacuum? In vacuum, it can travel at 3 into 10 raised to power of 8 meter per second. That means it can revolve around the earth. Earth के चक्कर वो 7 बार काट सकता है. 7 times it can revolve around the earth. It is a transverse wave. That means it is a wave that travels in a straight line. And how is the propagation possible? It is possible due to its electromagnetic properties. That means electrical signal is on the upward side and magnetic property on the sideways. That's why due to this oscillation, it can propagate further. It can move in a straight line. It can move in a straight line. So now let's go to reflection of light. What is reflection of light? We understood about light. So the way light behaves with different surfaces, we're going to see about plane mirror. We're going to see about concave mirror as another surface, which is part of spherical mirror, and convex mirror, which is also part of spherical mirror. So what is reflection? Reflection is, by definition, it is the bouncing of light when it hits a polished surface. And that polished surface, we can assume it as a mirror. For now, in your syllabus, we are going to cover mirrors when we are going to talk about reflection. What are the laws of reflection? कायदे कानून reflection के. So when we talk about laws of reflection, there is one single very important law, is that the angle of incidence, that means the ray of light hits on a polished surface, it reflects back at the same angle. It reflects back at the same angle. That means angle of incidence. Angle of incidence is equal to the angle of reflection. And subsequent to that same law, it assumes that all the rays, that is the incident ray and the reflected ray, with respect to the normal, all lie in the same plane. They lie in the same plane. If this is the plane, then all the incident ray falling on me and getting reflected, all of them lie in the same plane. So let us see about this particular mirror. This is a plane mirror, and this is the polished surface, and this is the reflecting surface on this side. This is the reflecting surface, shiny surface, right? The angle of incident at an angle I, which falls on the plane mirror, it reflects back at the same angle R. That means angle of incidence is equal to angle of reflection. The same when we talk about spherical mirrors. We have two spherical mirrors. One, the concave mirror. This is the concave mirror. Concave. We identify the concave mirror because the shiny surface, that is the reflecting surface, is on the inner side of the sphere. And then we have a convex mirror wherein the shiny surface is on the outer side. This is the outer side of the mirror, which is the shiny surface. And this is the inner side, which is the shiny surface of a concave. And this is the convex. As you can see, the laws of reflection hold good even for these mirrors, even for a concave and a convex mirror. That means the angle of incidence is equal to the angle of reflection, and all of them lie in the same plane. Few terms we have to remember with respect to the spherical mirrors. The center of the sphere is the center of curvature of the mirror as well, whether it's a concave mirror. Let me take a different marker here, green. This center here, this center here, or this center here is the same whether it's talk about concave or a convex mirror, because it's taken from the sphere itself. It's at the same location. And then we have a pole. This is the pole. The pole lies on the surface of the mirror. This is the pole. Pole of the concave mirror, which is on the surface. And then we have the focus. The focus point lies exactly at the center of the pole and the center between the pole and the radius of curvature, which is the center of the sphere. That means it lies, blue indicator, it lies here. This is the focus point. This is the focus point of the two mirrors. So now that we have understood reflection, here are the various terms. This is the center of curvature, the focal point we have seen. We have seen the pole, which lies on the surface, and the angle of incidence, angle of reflection, and the principal axis is the line connecting the pole and the center. Let's move forward. So now we are going to see mirror ray rules. What are the ray rules we need to remember? There are four ray rules, four rules which we need to remember. Okay, they're very simple to remember. After I cover the ray rules, I'm going to tell you how to remember them as well. So in case of a concave mirror, for a concave mirror, the reflecting side is on the inner side. So when we take the ray of light coming parallel to the principal axis, and it hits the reflecting side, and it reflects back through the focus. The next ray of light goes through the focus, then it will reflect back parallel to the principal axis. The third rule says that when the ray of light goes via the center, then reflects back via the center itself. The fourth rule is nothing but a very simple rule. Law of reflection, if you remember, the angle of incidence is equal to angle of reflection, which is also true in other cases as well. But it hit the pole, then it will reflect back. It will reflect back at the same angle. In case of a convex mirror, the reflecting side is on the outer side. For a convex mirror, it's a convex mirror. When the ray of light comes parallel, this is the white ray, when it comes parallel to the principal axis, it will diverge. It will diverge away from the reflecting side as though it is reflecting from the focus. The second rule, the ray of light appears incident as though it is passing through the focus. It will reflect back parallel to the principal axis. The third rule, this ray of light appears as if it is going towards the center. So it will reflect back on the same line. And the fourth rule, if it hits the pole, it will reflect back from the pole at the same angle of reflection. So these are the mirror rules you need to remember. And using these rules, we are going to form the images. So sign convention, few sign conventions you need to remember. The sign convention with respect to the distance, and the height. First thing we need to remember is all the distances are measured from the pole. Whatever distance is given in your questions, in your exam questions, we have to measure them from the pole of the mirror. You have to measure them from the pole of the mirror, whether it's a concave or a convex mirror. This is a concave, reflecting side is inside, reflecting side outside the convex mirror. So here, now when we measure the distance of the object, which is the sun here, because the sun's rays are incident from right to left. And when you measure the distance from the pole, you're going against the incident ray. That is why it is negative. All the measurements taken from the pole against the incident ray is negative. That means the focal length of a concave mirror is negative. The radius of curvature of a concave mirror is negative. The object always, the distance of the object is always negative because it's always on the reflecting side. Height of the object. If the height of the object is above the principal axis, then it's considered to be positive. Below the principal axis is supposed to be negative. Same for convex mirror. Here, the object is on the left-hand side because the reflecting surface is on the left-hand side, right? Now, the ray of light will come from left to right. Because the ray of light comes from left to right, all the distances from the pole measured in the right-hand side direction will be negative because you're going against the incident ray. And then when you're going from left to right, that means in this direction, positive direction is basically the focal length and the center radius of curvature is positive in case of convex mirror. I hope this is clear enough. सब बच्चे समझ गए तो अच्छा है. So you can please put your comments in case you didn't understand. Please let me know. I can make a short video. Okay. So now let us see, based on the sign conventions and the rules, whatever we studied, let us see what are the formulae which we can derive from here. Okay. For concave mirror, the focal point, the focal length is half of the radius. For convex mirror, the focal point is half of the radius. For a plane mirror, the focus and the radius of curvature is actually infinity because the plane mirror is straight. Okay. The concave mirror is a converging mirror because all the rays converge. And for a convex mirror, it is called as a diverging mirror because the rays diverge upon reflection. Now here we are going to see the image formation. So we are going to apply whatever rules, that is the ray rules we have studied, to derive our images. Now in the first case, this is the first case, this is the second case, this is the third case, fourth, fifth, and sixth. So there are 6 cases you need to remember for a concave mirror. So when the object is at infinity, the ray of light comes parallel to the principal axis. You have 2 rays of light. For assumption, we have used these parallel rays of light. They reflect back on the focus point. That means the image formed here is real. It is highly diminished, point size, and inverted. Right? So the second rule, the ray of light, when the object is very near to the center or at some finite distance from the center, then the ray of light, one ray of light we assume parallel and the other ray going to the focus, then the image is formed between the focus and the center as we see here. And this image is actually real, diminished, and inverted. The third rule, when the object is at the center, we take one ray parallel, other ray to the focus, and upon reflection, we see that the image is formed at the center itself, that is of the same size, inverted and real. Fourth rule is when the object is between the center and focus. Here also when the image is formed beyond the center, which is real, and it is magnified this time, and it is inverted. The fifth rule, when the object is at the focus, here also we take 2 rays, and when the ray parallel hits the surface, it has to move to the focus, and when the pole, it will reflect back at the same angle. So we see the image getting formed at infinity. The image is formed at infinity. Here, image is real, magnified, and inverted. Final case, the sixth case, is when the object lies between the pole and the focus. The green object lies between the pole and the focus. So here, the rays diverge from each other. So because the rays diverge, they appear to meet behind the mirror, and hence we can see a magnified image, and which is an erect image, and it's a virtual image as well, right? So a concave mirror is a very magical mirror. In fact, it can produce different types of images. It can produce magnified image as well as a diminished image, depending on where the object is placed, or even the same size image. It can produce a real as well as a virtual image as well. It can invert it or it can erect it, depending on where the object is. So now that we have seen concave mirror, we're going to see convex mirror image formation. So for convex mirror, here we have just two image formation cases. For concave, we have 6, and for convex, we have 2. The first case, this is the first case, and this is the second case. Okay, we're going to draw the rays. So the rays coming parallel to the principal axis will diverge out, and they will appear to meet at the focus. Here, what type of image is formed? Because it is formed behind the mirror, hence it will be virtual. It's going to be highly diminished, and it's going to be an erect image this time. In the second case, we have the object between infinity and the pole, anywhere between. So here what will happen? The rays of light will again diverge, but this ray which will appear to the center, which will diverge at the same, right? So here the image is formed between the pole and the focus. It is formed between the pole and the focus, because the second ray will reflect back in the same line here. And what are the characteristics of this particular image? It is virtual again. It is diminished and it is erect. So convex mirror always produces a diminished image, and it's always an erect image. This is supposed to be remembered. It's a virtual, diminished and erect image in all possibilities. Hence it is used in cars, rear view. We can see the object behind the car using the convex mirror. So this is the tabular representation of whatever we have studied. You can note down of this tabular representation. This is infinity, this is focus, and C is the center. Same thing for convex. This is for convex. And this is for concave. So as you see, for concave, we have 6. And for convex, we have 2 cases. Now for concave mirror I use in car headlights or in torches or dentists to see your teeth, so that they can see a magnified image of your teeth, right? And shaving mirror so that you can see yourself big, so that you can have a clean, good enough shave like me. And convex mirror is used in the rear mirror of a car, so that we can see all the cars, right? All the cars. We can see all the cars. And we can see small. We want small so that we can have a wider view, so that we can take out decisions based on who is coming behind us, or how many cars are coming behind us, or how close the car is relatively. Okay, these are the applications of a concave and a convex mirror. So finally, we have seen mirrors. We are going to see quickly about the mirror formulas. As we know, for the image to be formed, we need 2 rays of light. And the rays of light actually meet, it is called as real. And the rays of light appear to meet, then it is called virtual image. So these are the 2 formulas. One is the mirror formula, wherein 1 by focal length is equal to 1 by image distance. This is the image distance. And U is basically the object distance. And magnification, we have 2 types of formulas. One is based on height and one is based on distance. So height of the image by height of the object. And it's also equivalent to distance of the image with respect to distance of the object. And you have to remember the negative sign. In the mirror formula, we have positive sign. Here we use positive sign. And the magnification formula, wherever you have distance used, we use the negative sign. But for height, we use the positive sign. So these are all aspects about mirrors. We have seen about reflection. We have seen the properties of light. We have seen how light behaves on mirrors, plane mirrors, concave mirrors, and convex mirrors. Concave and convex are spherical mirrors. And then we have seen the ray rules for concave and convex mirrors. Ray rules, there are 4 ray rules for both mirrors, right? And based on these ray rules, we have seen how the images are formed. There are 6 cases for concave and there are 2 cases for convex. Concave is a converging mirror. Convex is a diverging mirror. Then we have seen the sign conventions. Sign convention, basically, if you're measuring the distance from the pole against the incident ray, then it is negative distance. When you measure from the pole along the incident ray, then it is positive. And height of the object, if it is above the principal axis, then it is positive, and below the principal axis, it is negative. So with this, we conclude about mirrors, and we're going to create a separate session for lenses. We're going to cover refraction through glass, and we're going to see all the aspects how light behaves with lenses. Thank you for watching this video, and if you have liked this session, please subscribe to my video as well. See you, bye.